Hello, for data communications and network one class today, Ajahn Sana will talk about error detection and correction. What is an error? Error occurs when the received bit is not the same as the transmitted bit. Okay? Look at the picture here. This is the send sequence and this is the receive sequence. You can see that if you send 1 but you receive zeros, okay, this means that there's error at this bit. And if you send 0 and you receive 1, there's another error at this bit, okay? So we have errors at the arrows here, okay? So this is the error, but we have basically two main types of errors, okay? The single bit error and the burst errors. Now, what is a single bit error? Single bit errors mean that we have like random error, isolated error, okay? And usually come from white noise. You may have heard of the additive white Gaussian noise, okay? So this is the main cause of single bit errors, and we don't know where it will occur, okay? And then we have another type, which is burst errors. Burst error is errors that have many bits, okay, close together, that are in errors, okay, but not every bit. You can see that this bit is wrong, but this is correct, and this is wrong, and this is correct, okay. If every bit in the burst is wrong, then it's very easy to correct it, okay? You just flip the bit, right? But because some of them are wrong and some of them are correct, you cannot correct by flipping all of the bit, okay? And this is the burst errors of length 10. The burst errors can come from impulse noise, okay, which has the high amplitude and short duration, okay. It can come from fading in the wireless channel when you send signal in the wireless channel, and sometimes the signal power fade, okay, and you lost the signal, okay. So this is the burst errors, okay. Now let's compare the error detection and error correction. For error detection, okay, the receiver will know, okay, that the received sequence contain errors. We will talk about how the receiver can know this in a little bit, okay. The error detection is quite easy to do, okay. You don't need many bits to add for the redundancy, okay. Basically, you have data here. This is the data bit, and these are the redundancy bit. We call it redundancy, right? Redundancy is usually we call this parity check bit, okay, or parity bit. And the whole thing we call this a code word. Okay, so the parity bit that we added, or in general, is we call it redundancy, okay. We can have very few, okay, undetected errors with not many redundancy bits, okay. And we have fewer undetected errors, okay, which is good, okay, compared to the error correction, which have more, okay, undetected errors, okay. Why does the error detection is better than the error correction in this sense? This is because the error correction has to do more than error detection, okay. Error correction has to know, okay, that the received sequence contain errors, and it has to be able to correct the errors also. So you have two jobs to do, okay, detect the errors and correct the errors, okay. That's why with the same redundancy bit that you add, okay, this part, okay. For example, you have let's say 3-bit parity, okay, with the same 3-bit parities, okay. You have more undetected errors because you have to also correct, okay. So your ability to detect is lower. For example, you may have 4-bit here, 3-bit here, and this is the data, and this is the redundancy, okay. Now let's talk about the probability and events, okay? If you send a frame, okay, the events that can occur is that you have no errors, which is good, or you have errors in the frame, okay? If you have errors in the frame, it can be either undetected or detected, okay? If you have no error, we call this probability P1, okay? If you have errors and it's undetected, we call it P2. If you have errors and it can be detected, we call this P3, okay? If we define PB, P sub B as the probability of a single bit error, which is sometimes we call it bit error rate, okay? This is maybe a more common name, bit error rate. Okay, so if you have this many bits here, so if the first bit is no error, okay, 1 minus PB, right? Second bit is there's no error is 1 minus PB. So every bit there is no error has a probability of 1 minus PB of occurring. If you want all the bit to be no error, so you have to multiply all this, which is equal to 1 minus PB to the n, okay, which is basically this formula. Okay, so this is how we compute PB. And you can see that the events, the three events, one of them must occur, right? So when you add P1 plus P2 plus P3, okay, it must be equal to 1. Okay, if you have no error detection, you just send it by only the data, okay, no check bit at all, only data, then P3 is equal to 0 because you cannot detect anything, right? So P2 is equal to 1 minus P1, okay, because it only 2 of these can occur. But if you use error detection, okay, then P2 will be very small, right? If you design the code well, okay, P2 will be very close to 0. Then P3, the probability that you can detect the error will approximately 1 minus P1. Now let's look at the parity check code. Parity check code is the easiest error detection scheme, okay? In this case, we use n minus k equal to 1. I told you about the code word before. Basically, k data bit, okay? Data, and this is total is n, right? N bit for code word. For the parity is n minus k. And in this case, n minus k equal to 1. So which means that you add only 1 bit redundancy to the data to make a code word. We have two types of parity detection. One is even parity detection, another is odd parity detection. The even and the odd parity is like this. For example, okay, if the data is 1 0 1 0 1 1, for example, okay, and you use even parity, you want the number of ones in the so use even parity here. What do you add? Okay, so you want the number of ones, okay, in the code word, okay, to be, so the whole thing is a code word here. You want the number 1 to be an even number, and you count the number here 1 2 3 4 is already even, so you add 0 here, okay, as the even parity bit, okay. And the whole thing, the code word will contain even number of ones, okay, and you send this to the receiver. If, okay, so you send this to the receiver, right? You send this to the channel and go to the receiver. If the receiver receives this and it gets something like, suppose there's 1 bit error here. So it doesn't know, okay, where the error is, but it counts the number 1. Now, sorry, okay, 1 bit error here, not 2 bit. So in this case, the number of 1 will be equal to 3, which is odd number. So something is wrong, so you detect error here. Because you use even parity, but you receive odd, right, number of ones at the receiver. So you can detect the error. Now, if you use odd parity, the same data, okay, if you use odd parity, what do you add? What do you add? You add 1 here, right? So that the total number of 1 will be equal to 5, which is an odd number. So you send to the channel, and then you get at the receiver, okay? If you have something wrong here at this bit, okay? So you count the number of 1. Number of 1 equal to 4, right? Which is an even number, right? So something is wrong, so you detect error. So this is how we do it. So you can detect the error when for both the even and odd parity, okay, when the number of errors is an odd number. So if you have odd number of errors, okay, odd number of errors means that you can have like 1-bit error, 3-bit error, 5-bit, 7-bit error, something like this. You can detect the errors, okay, because it will make the, suppose it's even before, right? If you add an odd number of ones error here, it will become an odd number at the receiver, so you can always detect. Now let's look at undetected error pattern. Undetected error patterns is the, for both of them, okay, is the case that you have even number of errors, okay. For example, if you have 2-bit errors, suppose in the same example here, you send 1 0 1 0 1 1 0, okay, with even parity, right? And 2 of them are wrong, so you receive let's say you receive 0 1. 2 of them are wrong, okay. What happened? The number of 1 is still an even number, okay. You cannot detect error. You think it's even number, so you receiver thinks that there is no errors, right? Because receiver only do what? Only check if you use even parity, and if number of 1 that it received is an even number, is considered the received sequence to be correct, okay. So you cannot detect this, okay. Another example, if you use an odd parity, okay, and then something is wrong here, so you get this. You count the number of ones is an 1 2 3 4 5. It's an odd number, right? 5, okay. So you can not detect either, okay. So you cannot detect the error if there is the error pattern is even number of errors, okay. So if you have like 2 error, 4 error, 6 error, something like this, you cannot detect it, okay. So this is the end of this slide, okay, and we continue with block code for next slide. Thank you.